Hey, welcome to Math with Mrs. Cameron. And this is our last Algebra 1 lesson of the year. Oh boy. So today we're going to be doing 8.4, which is solve polynomial equations in factored form. So the very first thing we need to learn is the zero product property. So, the zero product property states that any two numbers that are multiplied together to equal 0, one of those numbers has to be 0. So it looks like this. So if A and B are real and A plus B, sorry, not A plus B, A times B is equal to 0, then A equals 0 or B equals 0. And what we can do when it comes to polynomials in factored form is we can basically take the monomial or the polynomials that the binomials that multiply together to make a polynomial and substitute them in for A and B. So when we do that, we're finding out that either the first binomial is equal to 0 or the second binomial is equal to 0. So let's go ahead and do at least one example of that, okay? So if I have in factored form x plus 3 times x minus 5 is equal to 0. So I know that one of these binomials is equal to 0 because of the zero product property. So either x plus 3 equals 0 or x minus 5 equals 0. So what I'm going to do is I'm going to solve each of those pieces separately. So that means x plus 3 equals 0 or x minus 5 equals 0. And I'm going to do this the longhand way instead of doing it in my head so that you can see how I'm thinking, okay? So we have to solve this super straightforward one-step equation. Subtract 3 from both sides and we get x equals negative 3. Or we do the same thing with our other equation. We're going to add 5 to both sides to get the x by itself. And we're going to get x is equal to 5. So when it's in factored form, it's really not that hard. You just take both of your pieces, set them equal to 0, and then solve for your variable. So let's go ahead and move on just a little bit because you're not always going to get these in factored form. It's super nice when they are, but it's not guaranteed. So sometimes you're going to have to factor. And we're just going to do some really simple basic factoring today and not anything too complicated. So in order to solve by factoring, the very first thing we're going to have to do is factor our equation. So basically what we need to do is find the greatest common denominator. And the term that we're going to use is factor out. Factoring out is not exactly the same as dividing. We are dividing by that, but the number or the greatest common denominator doesn't actually go away. It stays there as part of your equation. So we're going to factor out the greatest common denominator. And essentially what that means is we're going to take whatever the biggest chunk is that we can pull out of all of the terms, or divide all of the terms by, and we're going to pull it out into the front of our equation. So that is going to look something like this. So if I have 8x plus 12y equals 0. So what we're looking for is what is the biggest term that we can divide 8x and 12y by. So they don't have any variables in common, so we can't pull out a variable. But 8 and 12 are both divisible by 4, which means that we can pull out a 4. So what we're going to do is we're going to divide 8 by 4 and we're going to divide 12 by 4. So we're taking our 4 and we're pulling it out to the front. So it doesn't go away, even though we're dividing this by it, the 4 stays here, okay? And so 8x divided by 4 is 2x, and 12y divided by 4 is going to be 3y. Now, we can't really solve this one because we have two separate variables, and so we can only speculate as to what x and y could be to make this equal 0. But in other examples, we can actually do better. So can't do that with this one because we have two different variables. So let's go ahead and do an example where we have the same variable so that we can actually solve by factoring. So I'm going to erase this. And let's go with 14y squared plus 21y is equal to 0. So we're looking, what number can we divide 14 and 21 by? And do we have any variables in common that we can pull out? So 14 and 21 are both divisible by 7. So that's going to be the first part that we're factoring out is the 7. Now, y squared and y are both divisible by y, which means we can pull y out of this. We're going to pull a y out. So essentially, we have our 7y, and then what we're going to be left with in our parentheses is what these are when you divide them by 7y. So 14y squared divided by 7y, so we have 14 divided by 7, which is 2, and we have y squared divided by y, which is y. So we have our 2y. And then we have 21y divided by 7y. 21 divided by 7 is 3. And y divided by y is 1, so we don't have to do anything with that. The y cancels. So with that is equal to 0. Now, because we only have one variable here, what we can do is we can solve. So we're going to take both of our parts, and we are going to set each of them equal to 0 so that we can solve them. So we have 7y equals 0, and we have 2y plus 3 is equal to 0. So we divide both of these by 7 so that we can get the y by itself and have y equals 0. And here, going to start by subtracting 3. So we have 2y is equal to negative 3. And then we'll divide by 2. And we get for our second possible answer, y equals negative 3/2. All right, so hopefully that makes sense to you. Remember, if you have any questions, feel free to reach out to me so I can help, okay? The last thing we're going to talk about is the vertical motion model. And this is basically about things jumping or being thrown and then falling back down. So we get to have a neat little formula that we use for that. So, the vertical motion model. Now specifically, this does, like I said, refer to things that are either jumping or being thrown into the air and then falling back down. So, our formula is h equals negative 16t squared plus vt plus s. So the important parts of this is h is the height of the object that is either jumped or been thrown. Negative 16t squared is the force of gravity on an object pulling it back down onto the ground. V is our velocity at which something was either tossed or jumped straight up. and then S is the initial height. So I'll go ahead and write that down just to make it easy so you remember. And of course, T is going to be our time in seconds. So FYI, this -16 is the force of gravity in feet per seconds. That number changes based on what units you're using. So we have H is equal to the height of the object. T is equal to the time in seconds. V is equal to the vertical velocity. And S is the initial height. So you can use this for all sorts of situations, but we're going to do an example involving dolphins. So if we have a dolphin and it jumps out of the water and it has a vertical velocity of 32 feet per second, we want to know how long it takes for that dolphin to enter the water again. So if our vertical velocity is 32, so I'm going to go ahead and write that down. We're looking for T, which is our time. The initial height, so we're talking about how long it takes for it to go from when it breaches the water to when it reaches the water again. So our initial height is going to be 0. So S is equal to 0. And the H that we're looking for, the height when the dolphin hits the water again, is also going to be 0 because it's 0 when it re-enters. And so we also have H is equal to 0. And then the only thing we have left to find is T. So we have 0 is equal to -16 T squared plus 32 T. And I'm just going to leave off the plus 0 on the end because we don't really need it. So what we can do now is we can factor. So what can we factor out of -16T squared and 32T? Well, first of all, they both have a T in common, so we can factor that out. And they both can be divisible by 16. And so what I'm going to do is I'm actually going to use -16. Just out of personal preference. I don't like to have negative numbers inside my parentheses if I can avoid it. So we're going to factor this. So we have 0 is equal to -16T, which leaves us -16T squared divided by -16T is just T. And then 32T divided by -16T. 32 divided by -16 is -2, and T divided by T is 1. So we're left with T minus 2. So now we can solve for T. We have -16T is equal to 0, and we have T minus 2 is equal to 0. So we can look at this, and I can already tell you this one is not going to be the correct answer because this would be T equals 0, and that is when the dolphin jumped out of the water. So this is not the one that we want to use. We don't want to know when it jumped out of the water. We want to know when it entered the water again. So we're going to solve this second equation. So we're going to add 2 to both sides of our equation. We're going to get T is equal to 2, which means that the dolphin re-enters the water 2 seconds after it jumps out of the water. So there we go. This is the use of a vertical motion model. You can use this same equation for lots of things. In science, they use it for rockets, or you can use it if you're doing trajectory for like a basketball, if you're shooting hoops. Yeah, so there's lots of different uses for this, okay? All right, so that's it. That's our last one. I hope you guys had a good year, and I can't wait to see you next time. Bye.